Good morning all of you, and let's solve some beautiful problems effective for J advance. And here is the first one. F of x is given and gt is f of x by t minus 1 to t. We need to find limit t tends to 0 gt by t. So as you can clearly see, we can make a substitution x equals ty, and with this substitution gt gets converted into minus 1 by t to 1 by t f of y t dy, and that gets t times t we can take out f of y dy minus 1 by t to 1 by t. Now since function is already known to us, so this amounts to t times of f of y e to the power minus y e to the power minus y dy, and we have even functions, so I can write it's 2 times 0 to 1 by t, and this gets evaluated to easily 2t e to the power minus 1 by t minus 1, because y is positive now, so you can clearly open mod y as e to the power minus 1, and that gives gt over t equals 2 times e to the power minus 1 by t minus 1, in fact it will be minus 2 times that, right, because minus sign will come out. So when t is tending to limit t tends to 0 plus, this quantity is going to be 1 by e to the power infinity, so it tends to 0. Similarly, this is tending to minus infinity, so we have the entire limit is going to be 1 to the power minus 1 to the power minus infinity, and that gives 2 as the answer. Let's study the second problem. 0 to pi over 2, fractional part of 10x. So clearly we can chunk the limit of integral into two parts, so that fractional part of 10x can be written as 10x minus greatest of 10x. Now we know as x is going from 0 to pi by 3, so 10 will go from 0 to root 3. So we have to break into two limits, 0 to 1 and 1 to root 3. So in 0 to 1, this integral can be written as 0 to pi over 4 10x minus greatest of 10x is anyway 0 over 10x dx plus pi by 4 to pi by 6, which is 1 to root 3 10x, and minus greatest of 10x in this interval is 1 by 10x dx. So it was an easy one because this becomes 1 dx. This integral is just pi by 4, and the another integration is pi by 4 to pi by 6 1 minus cot x dx. Now cot x integral is ln sin x. So using this information, if I'll keep this, the final answer that we are getting out of this is second integral is ln root 3 by 2 minus ln 1 by root 2. So finally we got pi by 2 minus pi by 3 minus half ln 3 by 2 as the answer. Let's move to the third problem. We have a function operating from 1 2 3 4 to a b c d e f, such that f of 1 is not a or f of 2 is b or both. And then the number of functions we have to count. So clearly if f of 1 is not a, so if 1 is not going to a, so how many choices there for 1? 1 2 3 4 5 choices. For 2, of course I have a is open, so 6 choice. For 3 6 choice. For 4 6 choice. So 5 into 6 cube. This is corresponding to f of 1 not a. Similarly, if f2 is not b, we have same 5 into 6 cube choice. Now we have also considered the case when both f1 is not a and f2 is not b. So under that condition, you can see we have to think of inclusion exclusion, because if f1 is not a and f2 is not b, right, so under this condition how many choices will be having? Of course 5 is square, into 6 square, because now f1 cannot go to a and f2 cannot go to b. So for 1 and 2 we have now only 1 2 3 4 choice available, right? If 1 cannot go to a, then 1 will have 5 choice, 2 will have 5 choice, and 3 and 4 will have 6 choices. So 5 square, 6 square. So now with principle of inclusion and exclusion, if we want either in a or b or in both of these numbers, okay, then by principle of inclusion and exclusion, let's say this is, it represents a set of f1 and this represents set containing f2. So what we wanted is a region in f1 union f2. So it will be number in f1 plus number of elements f2 minus number which is counted twice in f1 and f2. And just by plotting these values, it will give 5 into 6 cube plus 5 into 6 cube minus 5 square into 6 square, and that amounts to 260. So this was a good problem again on basics. Let's move to the next one, and it's a beautiful problem from coordinate geometry. So we have a parabola y square equals 4x. Let p11 comma b be any point inside the parabola. So let's say if you have some point p11 comma b. F is the focus, so clearly focus I can say it's 1 comma 0. If the point q on the parabola is such, so point q is randomly moving on the parabola such that pq plus fq is minimum. Now one way of doing this question is you can take a parametric point, let's say at square comma 2at, so t square comma 2t, and now you can write pq plus fq using distance formula. So pq is going to be t square minus 11 whole square plus b minus t2 whole square plus fq is t square minus 1 whole square plus 4t square, and it depends on t. Okay. In fact, b is also variable, but let's say for the particular b it depends on t. So this is a function of t, let's say psi t. From here I can differentiate, I'll make psi dash t equal to 0, we'll get a value of t in terms of b and accordingly we'll do, but that will be extremely lengthy, right? So this is not a very good approach. Of course you can get the answer, but it's not a good approach of doing this. So can you think geometrically? Yes, it can be done, because you know directrix of this parabola is x equals minus 1. So a beautiful property of focal directrix of parabola tells us fq is always going to be qm, right? So if fq is qm, then definitely if I want this plus this to be minimum, pq plus fq is minimum, it shows pq plus qm should be minimum, right? So this is same as pq plus qm should be minimum. Now we know pq plus qm will be minimum if and only pq and m are a straight line, so they must be collinear. It means point q must be here, right? So this is a new position q dash for its minimum configuration t square comma tt. Okay, similarly m will have the same coordinate minus 1 comma 2t. So that solves the problem. So it shows under this condition, minimum condition, b must be 2t, because the height of point p is same as height of point q is same as height of point m. Okay, so this was a beautiful geometrical approach. So once we got b equals 2t, next we can find the area of parallelogram they are asking, and r is a point of intersection of axis and directrix. Okay, so this point is given to be r, so we need to find area of parallelogram PQRF. So we have P, Q is the point, and R and F. So basically we have this parallelogram. Now its area is very easy because it's 2 times of area of the triangle formed by MQP, right? So area of triangle is nothing but half into base into height करके we can find, because base is already known. You see for this parallelogram base is known and height is known. What is B? Base is 2, so no need to use the determinant formula, we can do from basics. So parallelogram area is base, which is RF, which is 2 into height is b, and b is already 2t, so we'll get 40 as the area of parallelogram, right? And now we can find the value of t. So to get value of t, we know the slope of, since it's a parallelogram, so slope of pf is same as slope of qr, right? And r point is -1, 0. Q is already t square, 2t. So from the slope, we are getting b minus 0 by 10 equals 2t by t square plus 1. Now b is already 2t. So यहाँ से value of t that we are getting is 3. In fact, we'll get plus minus 3, but we are in the first quadrant, so value of t I am getting 3. So the area amounts to 4 into 3, which is 12. Let's check once whether it's 6 or 12. Area parallelogram is base into height, so base is already 2, height is b, and b we have calculated as 2t, so it will be 40, and t value is 3. Yeah, so that will give 12 as the answer. Okay, so this one you can check. You can check for 12 or 6. Yes, 12 will be the answer for this problem. Let's move to the next problem, and this is again interesting. It's interesting because we have so many information about matrix A and B. So trace of A is given, data of A is known, trace of B is known, data of B is known, trace of AB is known, and we have to find the value of x for which data of A plus xb equals 272. तो इसको how will you solve? अब देखो, since we have A and B is 2 cross 2 matrix, so one way of doing this is you can take A, B, C, D and E, F, G, H, but that will incorporate 8 variables. Okay, of course it can be done, but it will be extremely time taking, especially in the examination. Now we know for any matrix A plus xb, anyway for any number x, okay, A plus xb is going to be some matrix of 2 cross 2 order, and if we have a matrix M of 2 cross 2, we know from Cayley-Hamilton theorem is it will satisfy its own characteristics equation. So m square minus trace of m times m plus that of m times I will be 0, where I is identity matrix of order 2 cross 2. अब यहाँ पे instead of m, if I'll take a plus xb, right, so we'll get a plus xb whole square minus trace of a plus xb, anyway it's a matrix, times a plus xb plus that of a plus xb. The motivation was this will give birth to that of a plus xb term, which basically we want to find. Okay, now from the given information we know trace of a and trace of b in that. So what we can do is we can take trace on both sides. Trace of a plus xb whole square, right, minus a plus xb is any matrix, so it will be trace of a plus xb whole square plus 2 times of because trace of I will be 2 here, so 2 times of data of a plus xb is going to be 0. So this is the equation that we'll get, and now we can use the given information. So यहाँ से what we got is data of a plus xb, as you can clearly see, is half times of trace of a plus xb whole square minus trace of a plus xb whole square. So this is trace of a plus xb whole square matrix, but this is trace of a plus xb and then a square of that. So it is some number. Let's say trace of a plus xb is 4, then is 16. But if a plus xb trace is 4, then a plus b whole square trace will be something else, and that we have to find. Now we can decode this. So it's half times trace of, it can be written as a square plus x square b square plus 2 x a b, order matters, minus this is trace of a plus x times, because trace is linear, so we can reduce this like this. So now if we'll keep all the values over here, so it gives you right that of a, because again we know trace of a square minus, because see the given information can be now written as half times trace of a whole square minus trace of a square plus trace of a to trace of b minus trace of ab times x plus half times by symmetricity we can see it's trace of b whole square minus trace of b square times x square. Again you can see from the Cayley-Hamilton theorem, like we can calculate trace of m square minus trace of m whole square, taking trace on both sides, plus 2 times of that of m equal to 0. So we can relate that of m with respect to trace of m square and minus trace of m square. So this by definition from Cayley-Hamilton theorem, what we can see, not from the definition, this by consequence of Cayley-Hamilton theorem, first expression is that of a, second is trace of a into trace of b minus trace of ab times x, and third is that of b x square. Now everything is known because that of a is given, this information is given, that of a is given, and moreover that of a plus x is given. So if we'll put this, we are getting a quadratic 11x square minus 5x minus 250 is 0, which gives two value 5 and minus 50 by 11. According to the problem, I have to reject this because I want positive integer. Hence 5 is the answer for this problem. So I hope you must have enjoyed this, understood like how in a basic way we can solve this problem. Next question is from differential equation, and this can also be done in an easy way, because you can see we have a given differential equation, x belonging to this interval, and an initial condition is imposed. Then we have to answer the following. Now of course we can write this given differential equation as y dash sin x plus y cos x. A standard hallmark step is to put this in a linear fashion, x sin x. तो यहाँ पे you can see if we use integrating factor concept, so y sin x we are getting x cos x plus sin x plus constant. ठीक है. Actually what we can do is this is also perfect differential, because derivative of y is written here, y is left here, sin x का derivative is written here, so this can be written as dy dx of y sin x LHS equal to x sin x, and now just you integrate on both sides with respect to dx, and we x sin x integral by partial fraction is by integration by parts is x cos x plus sin x. तब यहाँ से अपने पास आ गया y इक्वल टू 1 माइनस एक्स कॉट एक्स, सिंस एट पाई बाई 2 output is 1. So now if we'll differentiate, so y dash will be x cosecant square x minus cot x, and that is giving 2x minus sin 2x divided by 2 sin square x. This quantity is always positive, and you know like sin 2x, say 2x will be more, so this is also positive in x 0 to pi by 2. So hence y is strictly increasing in 0 to pi by 2, y is strictly increasing in this interval. ठीक है ना. तो अब यहाँ से जो आंसर आ गया b, y टेंस मिनिमम वैल्यू इज 0 to pi by 2, so ये तो करेक्ट है. c is also correct, limit x tends to 0 y of x, y is given, you can clearly see this limit. Okay, x cot x जो है that is x by 10x, so limit x tends to 0 plus it will be 1, so 1 minus 1 is 0, and option D is y of pi by 4 is lying from 0 to 1. So from the minimum and maximum we have clearly shown in 0 to pi by 2 minimum over, so this value is also correct. So hence we have answer to this problem. I hope you must have enjoyed this session and how beautifully we have solved all problems.